Hello, everyone. I see that it's 3 o'clock already, so let's start. My name is Joseph Wittis. I'm from Cloudvisor, and I'll be hosting today's workshop, AWS CDK from Zero to Hero. With me, I have Laimonas Sutkus, serverless evangelist and the CTO of Biomapas. Laimonas will be presenting today's workshop, and yeah, I look forward to hearing more from him. Thank you all for joining this event. Just before we start, there's a few admin points from my side. First being that if you have any questions, they're very welcome. Please submit them in the Q&A section or the chat section, and we'll address them throughout the workshop. The second point, if you still don't have a training account, but you would like access to one, reach out to events@cloudvisor.eu, and we will give you access right away. And then lastly, this event is being recorded, and we will share the recording with everyone tomorrow. Now, this workshop is brought to you by Cloudvisor, and yeah, I would like to share a few things about us for those of you who aren't familiar with what we do. So Cloudvisor is an advanced tier AWS partner, and we operate in the Baltics, Nordics, and beyond. We are an AWS reseller, which means we work closely with AWS to support current and new AWS users. And did you know by switching your AWS billing to Cloudvisor, you can get access to one of 4 benefit packages that best suit your business. The first one being you'll be able to observe your cloud performance. Now, our AWS experts have created a state-of-the-art monitoring platform that enables you to track the performance of your cloud services 24/7. The second benefit package that you have access to is to donate 4% of your AWS spend to an NGO of your choice, or that is close to your heart. And the third option is to continuously modernize your infrastructure. Now, every time that your AWS spend accumulates to $10,000, you can get up to 5 hours of our team's expert AWS advice at 0 additional cost, as well as a yearly AWS well-architected review. Now, the fourth and very popular benefit package is to save on your AWS spend. So you can get an immediate 3% discount on your AWS spend and a 50% discount on the CloudFront service rates. So if your company is currently using AWS or you are thinking about using AWS, I strongly suggest that you inquire about these benefit packages that we offer. Now, before I hand over to Laimonas, I have one more exciting thing that I would like to share with you. And that is that we at Cloudvisor recently launched a loyalty program. And you can get rewarded for referring companies to Cloudvisor. And it's super easy. So you head over to the loyalty program page. I'll share the link with you afterwards. Then you just follow the easy steps. And once the company that you referred completes their onboarding, you will receive a prize. Now let's look at the prizes that you can choose from. So the first one is a personal prize, which is something like tickets to a music event or a wellness-related gift card. The second is tokens to purchase AWS or Cloudvisor services. Now, 1 token is equal to €1. And the third prize option is to donate to an NGO of your choice. Now, the value of these prizes are determined by 3 tiers depending on the monthly AWS spend of the company you referred. So the first level is if a company is spending up to €1,000 per month on AWS, your incentive prize will be €200. The second level, if the company spends €1,000 to €5,000 per month on AWS, your incentive value will be €600. And the third level, if the company is spending more than €5,000 a month on AWS, you get a whopping prize of the value of a whopping €1,200. So I really encourage you to take part in this loyalty program, as it is a win-win for everyone. Now, that's all from me. Laimonas, over to you.
Yeah, thank you, Joseph. Hello, everyone. Once again, my name is Laimonas, and I will talk today about AWS CDK, about AWS's way of managing your infrastructure as code. And for your convenience, I have prepared a few slides. Let me share my screen. I hope when you got your invitations to this event, you were shared a link to my personal GitHub page, where you can find all of the material, starting from this presentation and ending with the final source code of what we are about to build. But in any case, if you want, you can go to AWS CDK serverless repository. I'm just going to quickly paste to the chat. So if you want to save it for later use. And here you will see that there is the presentation itself and the source code that we want to build today. All right, without further ado, let's start with some short introductions, a little bit about myself. So it is, I don't know, maybe my fifth, sixth workshop with Cloudvisor. I've been partnering with Cloudvisor for quite a few years now, maybe 4. Both my previous company and current company are partnering with Cloudvisor for those mentioned benefits by Joseph. So when it comes to working experience, I'm currently a CTO at Laimonas, and my previous company that I worked with was Idenfi, a fintech-based startup, and there I was also a CTO. I have quite a few years of experience, I would say, in the industry, in the IT industry. It would be around 10 already. And out of those 10 years, half of them are based on AWS. So I tried to play with other cloud providers, but I don't know, somehow I got stuck with AWS, and I've been building infrastructures on this cloud platform ever since. So if you want to contact me directly, you can freely do so. Just write to laimonas.sutkus@gmail.com. I also shared my LinkedIn profile, which is Laimonas /Sutkus. And finally, I have my own GitHub page where I usually post workshop material prior to the events. This is true to the previous event, which was Cloud Formation from Zero to Hero. That you were able to find the whole source code there. So I really like this format. Moving on, a little bit about Laimonas. So Laimonas is a service-based company that works in life science industry, and Laimonas specializes in clinical operations, regulatory affairs, pharmacovigilance, and medical information. I have to be honest, when I started working in this company, all these words were just buzzwords for me. I did not know what they mean. But apparently working in life science industry, especially in the IT field of life science industry, is extremely challenging and extremely interesting. So if anyone wants to take a challenge on that part, you can try to contact me or write to info@laimonas.com. When it comes to technical side of Laimonas, we fully utilize AWS Cloud to build our products on. We embrace serverless architecture. We try to avoid EC2 instances and RDS databases. We try to build everything on Lambda functions, API gateways, event bridges, and DynamoDB databases, S3 buckets, and so on. Just to fully utilize the serverless stack and to be able to infinitely scale up and scale down at any point in given time. Our also all projects, one way or another, are related to artificial intelligence, mostly natural language processing. We are air quotes, listening to, let's say, phone calls between a patient and a healthcare professional. We are transcribing those calls and giving suggestions for healthcare professionals or agents in real time, for topics, for answers, and any additional material and everything that happens in real time. At the same time, we are following best CI/CD practices, and some of those I will share with you today, meaning that all the pipelines fully automate releases. We have mirror infrastructures thanks to infrastructure as code principle, and most importantly, thanks to AWS CDK. But yeah, I will show you some of those best principles later in this workshop. On the right side, you see the email, the LinkedIn, and what is, I think, really interesting about Biomapas, that Biomapas also has a GitHub page. And this is one of the initiatives from the IT department that when we were building this AWS CDK based code and serverless infrastructure, we saw that there are some code duplications that could be moved to a separate package, and that separate package does not expose any proprietary logic or business logic. So why not to open source that package and share with the IT community, with the AWS community? And basically, this is what we did. If you visit github.com/biomapas, you will see that there are from 20 to 30 open source packages, and almost all of them are AWS CDK based, meaning that they enhance the functionality of the AWS CDK tool in one way or another. Well, I will give you an example. We have created a custom deployment library that makes all of those CloudFormation stacks to deploy in parallel, because the default functionality of AWS CDK or CloudFormation is to deploy stack in sequence, in one line. But this is too slow, and we thought, why not to parallelize it? And this is what we did. And now we deploy all the stacks in parallel, saving significant amount of time when it comes to CI/CD pipelines. But again, we will get back to that part. So this is short about Biomapas, and let's.
Right, Laimonas, sorry, before you continue, do you mind just making your presentation full screen so that it's a bit easier for everyone to see?
Yeah. Is this better?
That is better, yes.
I can do. This is the best I can do, I guess.
That's perfect. Thank you. Sorry for interrupting. Continue.
Okay, awesome. So let's continue. So for today's agenda, what are we going to do? I'm going to shortly introduce you what AWS CDK is. Then we will straight jump to the workshop part. And for the workshop, we will need to install some tools, or at least I hope you have already installed them. We are going to install the CDK CLI itself. We are going to create and deploy a sample project. And then we will go advanced, and we will build a serverless HTTP API, where every single endpoint is backed by a separate Lambda function. I would call this a separate nano service. Lambda functions will be able to communicate with DynamoDB database, which is a serverless NoSQL database. And finally, we will use Lambda layers to share code, and we will use something called PynamoDB, Object Relationship Mapper. Apparently, NoSQL databases also have object relationship mappers, which is cool. Again, the PynamoDB is quite a convenient way to communicate with DynamoDB, because if you were to use Boto3 library or just simple API to communicate with DynamoDB, it is not really convenient. It is you need to write quite a low level code, which is not a preferred way in these days to write code. You want to write as abstract, as high level code as possible to increase your productivity. Finally, we will jump to writing some integration tests. And I think this is really, really interesting and important when we talk about infrastructure itself. So in order to test our application, we need to deploy infrastructure, run tests against that infrastructure, and lastly, destroy that infrastructure. This is the only correct way to test your code, to test your application code and infrastructure as code. Finally, we will create a GitHub repository, push code, and create GitHub Actions-based CI/CD pipeline, where we will automate that integration testing to create, test, and destroy the environment. And lastly, we'll go to the summary and some pro tips. Okay, so what is AWS CDK? It is not SDK, it is CDK, meaning it is Cloud Development Kit. And I will just read out loud to you. It is a framework that allows to define your infrastructure using a programming language. Well, for example, Python. And with Python, you can define things like EC2 instances, RDS databases, IAM roles, Lambda functions, HTTP APIs, and so on. AWS CDK is just a wrapper for AWS CloudFormation, meaning AWS CDK produces CloudFormation templates. And the actual deployment is being done by CloudFormation, not AWS CDK. So if any of you are not familiar with CloudFormation, I guess there will be a slight knowledge gap, because it would be really beneficial to, it would be really beneficial to firstly know what AWS is and how to create those EC2 instances, RDS databases, and so on via console, via user interface, and then switch to CloudFormation to try to mimic those actions using CloudFormation templates, and then switch to AWS CDK to try and mimic CloudFormation templates. I mean, these are 3 steps to reach full potential of AWS CDK, but don't worry, this is the workshop from zero to hero. So I will try to explain everything in easiest terms possible. But for you just to know that under the hood, AWS CDK is just a wrapper around CloudFormation, and CloudFormation is AWS's way to manage your infrastructure as code. And are there any alternatives to AWS CDK? Well, there are, kind of. So for example, there is a widely accepted Terraform tool that has its own language. We have Troposphere library, which is Python only. We have Chef, which is, if I remember correctly, Ruby only. Then we have Ansible, Puppet, and similar tools that are either YAML-based, JSON-based, or Bash-based. So, for example, if we tried to compare CDK with Terraform, I would always go with the CDK, because it allows to write you in your favorite language. Python, C#, F#, JavaScript, TypeScript, Go, and I think that's it. Maybe there are a few more. And well, Terraform has its own language, which is some kind of JSON on steroids, which I don't know, it doesn't seem to me very human readable. For me, Python is human readable and JSON is not. So I would prefer things like CloudFormation. Okay, I see there is one question. Let me read it out loud. So, hi Laimonas, you mentioned about multiple CloudFormation deployments in parallel, how the dependencies are managed if we wanted to reference the resources in another CloudFormation. Awesome question. I like these questions. It means that attendees really have some knowledge in AWS services and understand the problems, let's say, in using some of them. So the way we parallelize those deployments is we take all of the stacks. Let's say if we have a big project, there could be up to 50 or 60 or 70 stacks. And we build a dependency tree. And once we have built this beautiful dependency tree, we start from the top with the leaflets, and we look at the stacks, the top stacks that don't have any dependencies, and we try to deploy everything. Once all of those stacks are deployed, we go one level down and we deploy second level of dependencies, third level, fourth level, and so on until we are down to roots, to the single mother stack. And this is how we manage this parallelism with dependencies. Obviously, if one stack depends on another, you cannot deploy them in parallel. But when it comes to big projects, some of those stacks, go like branches, and those branches are independent, and those branches can be deployed in parallel. And this is where you save quite a lot of time. And yeah, but we will get back to that. Okay, fine, let's go. So when it comes down to prerequisites, what we're going to need. Firstly, we're going to need Node.js and NPM. And these tools are required to install AWS CDK library. It is written in JavaScript or TypeScript. Secondly, we are going to define our infrastructure, our resources using Python, as this is my favorite language, and apparently it's now the most popular language in the world. But again, you can switch to Go, C#, TypeScript. We would preferably also need to have Docker, and we are going to use Docker to build dependencies for our Lambda functions. And again, I will explain what dependencies for the Lambda functions are when we will start on our workshop. And finally, it is an optional one, some kind of HTTP API debugging tool. I really like using Postman, but other tools like Insomnia and so on are very well suited for that. All right, so let's
Laimonas, excuse me again, sorry, another question from an attendee before we continue. So the person asked, if someone is already good with Terraform, would you recommend them to invest time in learning CDK? Is there any considerable advantage?
Okay, so if you already are pretty good in Terraform, stick to Terraform. Because you probably already are pretty efficient and you are making money, making salary with what you do, and starting to learn AWS CDK is probably not going to yield any significant improvements in the short term. So I would simply stick to Terraform if you're good at it. But if you're new and you're just deciding which technology with which technology, what technology to start with, then my recommendation would be go with AWS CDK. Again, just a fun fact. There is even an AWS, like again, air quotes, AWS CDK version for Terraform. If I mentioned to you that CDK is the one that can produce CloudFormation templates, so I think AWS CDTF. I'm not sure what's the name. You can always Google that. So there is a library, again, purely based on the same technology that produces Terraform templates instead of CloudFormation templates. So you might want to invest maybe your time in that part. But yeah, this recommendation, to use AWS CDK is rather for the new guys that try to decide which technology to use. Okay. I hope everyone has their working AWS account ready. I hope everyone has their terminals open. And the very first thing that we need to do is to install the tool itself. And the command for that is, well, you can see that on the screen. If you type npm install global AWS CDK at 1x, one-click disclaimer. 1x means that we are installing the first version of CDK. Guys have launched now the second version of the CDK, but it's still not really stable. So I would still not recommend using it, even though that when you start using the first version, they already show you that it is going to enter some kind of maintenance mode. But it's totally fine to use the first version as it is the most stable version right now, and there aren't very significant differences between first and second versions. You can always do that migration once you feel comfortable that the second version of the CDK is stable enough. Okay, and this is what we're going to do. I think for me it is going to crash. No, it didn't. Because it usually crashes for me when I install this library if I have it. Okay, and just to verify that everything works, we can simply type cdk-version, and we will see that it is 1.152.0. And quick, again, disclaimer. CLI versions match Python or Go or C# libraries versions. So for example, if you want to start building Lambda functions, you will need to install AWS CDK Lambda package, which preferably should be similar version to your CLI version, but it is not a strict requirement. Okay. Going further, now, in order to initialize a new CDK app, a new CDK project, we need to initiate the first command. And let me quickly go to desktop. Okay, and let's initiate something. So make dir, let's call it workshop, and in that folder let's initiate the CDK application. CDK init And this is where we are going to specify our language. So if you're writing with Go, you would write something like that. I mean, you can write without anything, and it will show you what are the available languages. So, for example, what do we have here? We have C#, F#, Go, Java, JavaScript, Python, and TypeScript. So for this workshop, we are going to do CDK init -- language equals to Python. Okay, and it will generate all the files and everything. It's, well, similar to using other frameworks. For example, something like Angular. If you init an Angular project, you will also get a bunch of files in your desired folder. So this is what we have. This is what CDK init has generated for us. And let's use some IDE. I like PyCharm. So let me quickly open that folder. Okay, let us investigate a little bit on the structure that has been created for us. So the first folder is the virtual environment for Python. It is Python related stuff, not CDK related stuff. This is the preferred way to work with Python projects. The Python project should have its own virtual environment where you put project related dependencies and configurations. The second folder is tests. This is where you would usually put your tests. And the official documentation of AWS CDK shows you. Okay, could you please zoom in your screen? How do I do that? How do I do that? Use custom font. Let's use 22. Let's see whether it works. Oh my God. It made the whole ID bigger, but the appearance, system settings, font color, scopes, editor. It should be somewhere here. Listen. Okay, font color scheme, inspections. Let's try using fonts. Here we go. Let's use something like 22. Okay. Is it better? I think Command plus does not work. Let me try. No, it does not work. It's not Windows. Okay, awesome. Yeah, going back to the tests. So official AWS CDK documentation states that in order to test your CDK application, you need to write tests, and you should write unit tests. And anywhere where you Google something like how to test your infrastructure as code applications, everyone is going to give you examples like these, where these are rather, unit tests where you check that the generated template has the specific resource and has the specific configuration of that resource. And I think that is quite useless. I don't see much value in that because checking that resources exist with certain configurations does not ensure that your application works, and does not ensure that the configuration between resources allow fluent communication. And this is why I believe that the only viable testing option is the end-to-end testing or integration testing, where you actually need to deploy the whole infrastructure, use it as a black box. Let's say it exposes some endpoints, and you hit those endpoints. You supply some information, get some information back, and you then assert whether that return information is correct or not. So this is what we are going to do at the end of the workshop. We are going to write at least a few integration tests. Now, the workshop itself, the folder is the source code folder. And there you will find your first stack created for you. And this is what we see. We see workshop stack. We see some parameters for the constructor. And here we have an example where we can create an SQS queue, give it the stack, ID, and some configurations. Git ignore, again, this is Git related stuff. App.py is basically the entry point of your CDK application. It should preferably never be modified. You can leave it always as this. CDK JSON, also AWS CDK related configuration file, doesn't really need to be modified unless you really know what you're doing. But mostly those two files can remain untouched. README.md is simply documentation for how to use AWS CDK, some activation of virtual environments, installation of requirements, syncing it, and finally deploying your infrastructure. When it comes down to requirements, this is what we're going to see. So things like .core and dot assertions are AWS CDK Python libraries. And if we go back to our terminal and hit CDK-version, we'll see that the CLI version matches the Python packages versions. And usually this is how releases are structured. When a new version is released, it is released throughout all of the packages, regardless if it's Python or Go or Java or whatever, and regardless if it's a CLI or not, the new version is deployed throughout the whole ecosystem. So the latest version, as we can see right now, is 1.152. When I was preparing for this workshop, the latest version was 1.150, I think so. They already published 2 new versions. So this is quite an actively developed product, and this is something to be excited about, to be happy about, that it is not going to become obsolete anytime soon. Okay, we have requirements -dev.txt. This is testing related stuff. We are going to use PyTest, definitely. It's probably my favorite testing framework for Python. And if you are a Windows user, you have an ability to activate your virtual environment just by simply executing this .bat file. For Linux users or Mac users, this is not mandatory. Okay. Now we have initiated the project. Now according to our agenda, let's try to deploy it. And just for us to be able to deploy, let's create a sample resource or simply uncomment this SQS queue. For those who don't know what SQS means, it's an abbreviation for simple queue service, meaning that you can have, with such service, you can have producer and consumer architectures and not worry about whether the, let's say, producer has better performance than the consumer. Let's say producer produces more information that the consumer can consume. This is where SQS comes in. It can have big buffers and handle all those traffic spikes, and the consumer can consume all the information at a steady rate, at the pace it can handle. So creating SQS queues is really simple, as you can see, not much configuration. Let's open terminal. Let's also source.env activate. This is Python related command to activate your virtual environment. And we also need to install all the dependencies as per README documentation, right? So this is what we did, sourced. And now we are going to install all the requirements. Okay, and once we have installed all the requirements, we can do two things. So if our project is small enough, we can immediately write CDK deploy -- all. But if our project exceeds something like 50 kilobytes or some amount of space, I don't remember what is exactly, then we will need to execute the CDK bootstrap command. The CDK bootstrap command will create an S3 bucket inside your application, inside your AWS account. And it will store all the assets and artifacts in that S3 bucket. So again, I hope everyone has their AWS accounts configured. You can check that by going to Vim, by editing vim.aws. Sorry, I mean I should go to my home page, vim.aws.credentials file. I'm not going to open that, especially when the screen is being recorded. But this is where you set up your AWS-based CLI and AWS-based account. Okay, so let's simply try to do the CDK deploy -- all, and let's start adding some resources. And at some point of time, we will get an error, and we will all be able to see what kind of error we get if we don't write CDK bootstrap. All right, so here we go. CDK deploy -- all. Okay, what do you want from me? Name SQS is not defined, of course, because I haven't imported that, right? So in order to use that, we always need to import those modules. Okay, it's a good start. What else I have forgot about? Cannot open AWS CDK from AWS unknown location. Of course, let me simply activate the virtual environment, go to requirements.txt, and as you can see, we don't have the AWS SQS-based library, and it should turn red now. Yes, meaning we don't have it. So simply we can go here, write AWS CDK dot AWS SQS. And we are going to install the requirements once again. And just for your information, basically every single AWS service has its own AWS Python-based package. We can go to, let's say, AWS CDK PyPy. PyPy is Python package index, and we can see all of the packages that belong to AWS CDK. So something like custom resources, core, X-ray, SSO, step functions, and so on and so forth. Every single service, there is a library. So SQS and SNS are similar services, and here you can see there is the whole documentation on how to use those libraries. Okay, so we have installed the SQS. If we go back now, we see that it is already recognizable by the project, and I'm pretty sure everything should deploy right now. Okay, so we see that the workshop stack is being deployed. We see some information in real time. Create in progress of SQS queue. And these things shouldn't take too long to deploy an SQS queue. It will be up to 30 seconds to 1 minute. And at the same time, as we are waiting, we can observe the same thing. Let me quickly open my Cloudvisor workshop account, just to show you that the same thing can be observed within the CloudFormation. So here we have logged into the console, and if we go to CloudFormation, as I told you previously, AWS CDK is just a wrapper around CDK. Sorry, about CloudFormation service. CDK is just a wrapper for CloudFormation service. So we can see the same things happening via console, via CloudFormation service. If we just go to events, we are going to see exactly the same stuff as we saw here. So it's completed the deployment, and at the same time, we can also see that we have successfully completed the deployment. If you have a brand new account, this is the only stack that you're going to see. As I have played prior to this workshop, I have 2 other stacks that have way more resources, but let's currently stick to only this one. And since I already have the CDK toolkit, I will no longer need to write the CDK bootstrap command, but if you have an empty AWS account, you should definitely write CDK bootstrap. And this is, as I told you, is going to create an S3 bucket. So now if we go to S3, and S3 basically means 3 S letters, SSS, and it's an abbreviation to Simple Storage Service. And here we can see that we have this bucket, and if we go inside it, we have assets, and this is where we have all of our artifacts, all of our builds, for example, Lambda function codes, Lambda layer dependencies codes, and things like that. If you were to write pure CloudFormation templates by your own, it would be extremely annoying, extremely difficult to upload this Lambda source code, to upload all the dependencies by yourself. It would be just a hectic experience. But what AWS CDK as a wrapper on CloudFormation service does, it gives you some of the functionalities that are extremely convenient. So for example, again, these dependency management between stacks, asset management, artifacts management, Lambda code build in real time and uploading to S3, so you don't have to worry about anything like that. So this is one of many reasons why you should use the wrapper instead of the CloudFormation service on its own. Okay, so we have created a stack, our first stack. If you go to resources, here is where we're going to see our deployed resources. And this is the SQS queue that was built. We can quickly check whether it's actually there. Yes, so it is indeed there. It is fully operational, as I can see. But again, I'm not here to tell you how CloudFormation works. I think we have a good video of previous workshop on CloudFormation and CDK, and this is where I want to purely focus on the CDK part. Okay. Going back to our agenda. So this is what we want to do, right? We want to create an API gateway HTTP API. We want to create Lambda functions for CRUD actions, so create, read, update, delete. We want to create a DynamoDB database. And finally, we want to use Lambda layers to share code between Lambda functions and share dependencies also. So for example, PynamoDB is going to be a dependency, a Python dependency to be shared between Lambda functions. Okay, so I would suggest starting from CRUD actions, create, read, update, delete actions, and creating a Lambda function for each action. So I will just simply create a new folder, call it CRUD, and let's create 3 separate folders. So one is create, another is read, updates, and finally delete. Okay. Whoops, this should be inside. Okay, and these are the folders that are going to contain this the source code of Lambda function. So every single folder could have, let's say, something like an index.py file, and let us create some boilerplate code. Let's say define handler, which takes any amount of args and named args and simply prints hello world. Okay, and this could be duplicated to every single folder. Now, we have simply defined the source code for the Lambda functions, but we haven't defined the Lambda function itself. So in order to do that, we need to import AWS Lambda. But again, as you can see, it is red because we haven't specified that dependency. And it's really simple. We just go to requirements.txt and we specify a new dependency. Let us install it. And as you can see, some of the dependencies that have been specified here have their own dependencies to other AWS CDK packages. So if you go something like pip freeze to list all of our Python-based dependencies, we see that AWS CDK-based dependencies are quite a lot more. I mean, we have something like IAM, KMS, logs, S3, signer, SNS, SQS, SSM, and so on. Simply because some of those packages have their own dependencies to other Lambda, other AWS CDK Python libraries. Okay, we have installed that. Going back, now it's no longer red. Let's call it AWS Lambda as Lambda. Lambda is a Python keyboard, apparently. You know what? I will simply import it like that from AWS CDK.lambda import function. So function is a Lambda function. Okay. And let's try to create one. Simply go function. And this is where we are going to be presented with a lot of parameters to be supplied. Thankfully, almost all of them are optional, and only mandatory ones are the scope, ID, code, handler, and runtime. Now, when it comes to scope and ID, these are not CloudFormation related parameters. These are AWS CDK related parameters. And every single time you're going to create a new resource, for every single resource, you will have to specify these two parameters. As you can see in the SQS queue, we do the same thing, but we just apply positional arguments, not named arguments. But if we go to the queue itself, we see again that we need to supply the scope and the ID. What are those and what do they mean? Well, the first parameter specifies the stack, the CloudFormation stack, in which this function should appear in or should belong to, right? So if you have, let's say, multiple stacks and you have multiple functions, you can specify different stacks for different functions. You don't have to put everything in a single stack. You can, divide your application into smaller pieces, into smaller stacks. So this is where you specify the CloudFormation stack in which the function will be put in. Now, the ID is purely AWS CDK based parameter, and it is simply a way for AWS CDK to determine uniqueness of different constructs of different resources. So every single resource should have its own unique ID. I'm not entirely sure why AWS CDK developers did it that way, I think in some scenarios we could have had this framework without this parameter, because honestly it is quite annoying for me that I need to specify it over and over and over again for every single resource. But it is what it is. It is what we have, and we need to specify those IDs. So just to underline that those IDs ensure uniqueness of your resources, and they must be unique within the same stack. However, if you have the function, myCool function in one stack, and you have myCool function in another stack, these are two different stacks and they won't clash and everything will work just fine. Okay. With this out of the way, all other parameters that we are going to supply are CloudFormation-based parameters. If we go to inner source code, we can see what are the possible parameters to supply, and honestly, there are quite a lot of them. Thankfully, in the doc string, we have a pretty good documentation of what each parameter does and what each parameter's default value is. But as I told you, for us, we are interested in simply code, handler, and runtime. Okay, so when it comes to code, this is where we specify Lambda functions code. And for that, we need to create a new instance, which is code. Again, we import a new class from the AWS Lambda module. And we have a few static functions from asset, from Docker build, or from inline. So from inline allows us to specify code simply with Python string. From asset allows us to specify a path to some existing Python folders and files. And this one is really interesting, from Docker build. And this is where you can specify a Docker file where it will be used to spawn a new Docker instance and execute some custom commands within that Docker instance. So for example, install some dependencies, delete some of the code, or modify some of the code, modify permissions and things like that. Well, some very, very custom and specific stuff. But for now, we will just simply use something from asset. And it takes, again, quite many parameters, but the only necessary one is the path to this source code. And thankfully, we have already created source code for ourselves. So we can either specify somehow like that, CRUD/create, but I really don't like the way it looks. I like to make everything dynamic. So what I usually do when I specify paths of the same project, I go to the root init file and I have some global variable. Let's say I will call it CRUD root, and I will call directory name, dir name, absolute path, again from the last, of this file. And I know this is quite a magic line for you guys, but basically in the runtime, what this variable returns us is the full path to the CRUD directory, absolute full path to the CRUD directory. And now instead of having something like that, we can have something more beautiful like that. CRUD. Whoops. How did I call that? CRUD. And now we can beautifully import it and have it as a dynamic import. And now we always know that this is going to refer to this folder, even if we move it somewhere else. And now we have CRUD, and this is no longer necessary. So CRUD/create is going to point to the inner contents of this folder. Yeah, this is as easy as it gets to specify your source code from existing files and folders. Now we need to specify the runtime. And obviously it is going to be Python. Let's take the latest one. And lastly, we need to specify the handler. And this is going to be index.handler. Now, again, it might seem as a magic line. So let me explain it to you. Handler basically means it tells for a Lambda service which Python function to invoke when the overall Lambda function is invoked. So we tell that when our Lambda function is invoked, please go to index.py file, find the handler method or handler function, which is this one, and execute it, run it. So this is basically telling what is the entry point of your program. And again, the runtime tells you which interpreter to use. This could be even something like Java 8 or 11, but again, we would need then to specify a bit different codes. So let's get back to Python 3.9. As we have this function defined, I think there is nothing else that we need to do, and we can simply try to deploy it and see how it goes. Okay, one cool feature of the AWS CDK is whenever you are creating an IAM role, it explicitly asks you, are you sure you want to create those IAM roles? Because some of the IAM roles can have admin-based policies, and this is where some backdoors start to happen in your infrastructure. So AWS CDK is very explicit about that. So yes, I'm aware I'm creating a new IAM role, and you might have a question. We just created a Lambda function. Where does this IAM role come from? We haven't specified it anywhere. Well, this is again one of the cool features of AWS CDK, is that if we are creating a Lambda function, we always need to specify a role for it. And within that role, we would specify the permissions that the function has. For example, it might have a permission to put an item into a DynamoDB table, or it could have a permission to put a document in an S3 bucket, and so on. If we are not specifying that, AWS CDK creates a default role for us, which is an empty role. It doesn't have any meaningful permissions, and it allows us to save quite some time, and it allows us to save some real estate in our project, and have this more readable, more beautiful code. Because creating a role is definitely more than these 6 lines of code. Okay, our deployment was successful. If we go back, and if we refresh it, we see that we have created this new Lambda function. We even have a reference to that. And if we open the Lambda function, here it is, the handler function. We can even test it. Let's have the test event name and save it, test it. And as you can see from the logs, we have the hello world. We have a fully now functional working Lambda function. But it definitely is not a create function, right? It doesn't create anything yet. We will go back to it in later stages of this workshop. Okay, so we have created one function. We need to create 3 more, right? For that, I would, at this point of time, as I have architected quite a lot of serverless infrastructures, I would consider having maybe multiple stacks, maybe multiple classes, just to divide my code into smaller, more readable, more manageable pieces. And this is exactly what we can have right here. Let's have something like let's have another stack. Let's have a CRUD stack, right? And we can simply copy all the code from here, rename the class to CRUD stack. We don't need these things. We might want some Lambda functions, but there are better ways to define it. I really don't like the way AWS CDK forces you to use their philosophy of calling the libraries and dot and then the class name. I always like to import them directly, just like that, and it again saves some real estate in my file. So this is what I'm going to do. We don't need the SQS queue, and let's define more functions, right? So let's define the delete, the read, and the update. Now, when it comes to function names, if you have observed, we have a quite ugly function name, which is the name of the stack, the name of the function, and some random letters to avoid clashes between AWS CDK resources. And again, this is where I told you that I really don't like this parameter, and I think the developers of AWS CDK could have avoided this in one way or another. But again, this is what it is. Thankfully, we can control the name of Lambda resources, of Lambda functions. There is a parameter called function name. Okay. And this is where we can specify a beautiful name for that. Let's say create function. Okay, and the ID could be exactly the same, because the name, this parameter and this parameter, they don't clash. Okay, so here we have create function. Here, let's have the delete function. Again, function name. Here we can have the read function. And finally, here we can have the update function. Now the only thing is missing that every single code parameter is referring to the same folder. We need to change that. So this one is referring to the create folder. This one should go to delete, this one to read, and this one to update. And just to make sure that things have been deployed successfully and separately, I'm going to call this update. I'm going to call this read, delete, and finally create. Okay. Now, simply executing the deploy command will not work. It will tell us that everything has been deployed already, except this time. Why? Because we have changed the source code of the Lambda function, and the AWS CDK or CloudFormation have noticed that the source code have changed, and they are initiating the new deployment of that Lambda function. And it's done. But again, if we go back, we are not going to see those new Lambda functions. Please ignore these Lambda functions as they have been modified 1 day ago. And a matter of fact, let me delete this serverless stack so it won't bother us. It should be quite quick action, but let's leave it as it is. Okay, if I'm going to refresh, nice. All of the functions have disappeared because we are deleting the stack that has created those Lambda functions. Awesome. So we can still see that our new functions that have been defined within the new stack did not appear here. And the reason of that is that we haven't initiated this class, this stack anywhere. So ideally, all other stacks should be initialized within the parent stack, the workshop stack. And this is what we're going to do. I'm simply going to delete all of the code. And I'm going to import the CRUD stack. And again, it asks for some scope, construct ID, and so on. And this is what we're going to give him. Scope, again, to which stack the child stack is going to belong to, right? So this is the parent stack, and this is what we're saying. This is going to belong to this parent stack. The ID of that stack could be named as CRUD stack. And even stacks have an ability to modify their names. It is called the stack name, and we can call it exactly the same, CRUD stack, right? Is anything else left to, not ID, construct ID. Okay, and just to avoid clashes between this old Lambda function and new Lambda functions that are created here, I am going to simply now delete that workshop stack. Okay. And again, it shouldn't take too much. Okay. And now, since we have initialized this stack, the CDK will look into this stack's resources. It will find 4 different Lambda functions, and it should create them. So let's try that. Let's try CDK deploy. I think this has almost completed. Okay, now, as you can see, if we have a stack that needs to be updated, but its status is something like delete in progress, rollback in progress, and some other very specific statuses that indicate some deletion of resources, it will not allow us to execute this command, meaning that will not screw up our CloudFormation templates or the infrastructure. Okay, and now it is definitely deleted. We can simply execute the command once again, and we see that it's deploying. Okay, again, so the reason is why I created a separate stack instead of putting everything into a single stack is that, well, it is a good idea. It is a good pattern to divide your application into smaller pieces. And there are a few reasons for that. So first one is that stacks themselves have a limit of how many resources they can contain. When I started playing with stacks, they had 200 resources limit. A few years ago, they upped that limit to 500 resources per stack. But in any case, we still have this limit, and ideally, we do not want to hit that limit, right? Another reason is code quality, and it's just easier to manage when you have these separate stacks, for example, here, and you can simply know that the CRUD stack, let's say, contains only Lambda functions. The DB stack only contains database resources. The API stack only creates API-related resources, and so on. It's just to make your code, to make your infrastructure, to make your templates more elegant and more manageable. Also, there is a third benefit that I just remembered from the question of parallel stack deployments. If you have enough stacks, let's say 20, 70 stacks or so on, not every single stack is going to be dependent on each other, right? You're not going to have a messy dependencies, but you're rather going to have a dependency tree. And we have developed this library where it can find those parallel stacks that can be deployed in parallel, and this is where you're going to have significant performance gains instead of having a single stack which deploys resources quite linearly. Okay, so here we can see that the deployment was successful. And if we refresh, now we see beautiful names of our Lambda functions. And if we go to read function, it contains hello world read. And if we go, let's say, to delete function, it should contain the words delete. Awesome. So this is how we create Lambda functions. Let's go back to agenda. I think we kind of have completed this part, create Lambda backends for CRUD actions. Now it would be a good idea to create an API instance and combine those Lambda functions under a single API. And now in order to do that, we have two ways to do that. We can go the traditional way, and we can go to requirements and install API Gateway version 2 service, right? And create things there. Or we can go a little bit more advanced way and use Biomapas written library, which is, again, simply a wrapper around this API Gateway version 2 library, but it contains way more functionalities. So if we go to GitHub and we go to Biomapas, I'm going to look at biomappers repositories. You see there are quite a few of them. We see there is BCFN API version 2, and the description states like that all nice features for API Gateway version 2 that are missing from API Gateway version 1. And yeah, so the main idea of this library is to enable all the features from API Gateway version 1 that API Gateway version 2 lacks on. And in order to install it, we simply use pip install bcfn API version 2. And again, it's just a bunch of AWS CDK dependencies. Okay, and it should be done in just a moment. Okay, and as you can see, we have a few dependency clashes. Like for example, some of the libraries want to have an older version, but we're going to have a newer one. This is usually not a problem because differences between, let's say, this version and this version are minuscule and usually never impact your development. So let's simply go to pip freeze API. Whoops. And we see that we have installed BCFN API version 2, which is 1.1.1 version. Okay, so add that dependency. And now we can create an API instance for that. To import it, we can go from BCFN API v2 API import API. Okay, and going back to the documentation part, which is for some reason very small. Okay, we have an example here, right? To create our resource API is exactly the same as creating the CFN API resource. So we can simply copy that and paste it here. And instead of scope, we are going to specify self. It is going to belong to the parent stack. So again, we are specifying the ID, the name, some description. Let's create a cat API. So cat API to manage cats. There are two types of APIs within API gateway. It is either HTTP protocol based or WebSocket protocol based. Both of them are very, very powerful. We are going to allow get, put, post options and delete methods. We are going to accept origins from any domain, and we are going to accept these headers. It is as simple as that to create an API, but we cannot deploy this API just yet because it doesn't have any endpoints. And every single API should have at least one endpoint to be able to be deployed. But before that, let's make, again, everything elegant and everything beautiful and create a separate stack for the API. Let's not put in the root stack, right? So let's create a new file and call it API stack. We can simply copy that, rename it to API stack. Let's not change anything there, and simply move the API definition to a separate stack. Okay. So here we have a separate resource, and now we need to create at least a few endpoints, and I'm really honestly too lazy to write them over and over again. I'm going to cheat a little bit. I'm going to this workshop material, or even better, we can go through GitHub. I'll just simply go to my repositories, AWS CDK serverless, source code, okay, backend API, and these are the resources that create those endpoints. So I'm going to be really lazy here. I'm just going to copy all that code, but don't worry, I will explain everything, what it means, what it does, and what's the reason behind every single line of code. All right, so let's simply paste it here, import some of those libraries. You should be able to import them just fine because all of them are part of BCFN API version 2 library we just installed. So we should have everything here. Okay, some CFN outputs. Okay, we cannot import these instances just yet, but before we do that, firstly, let's talk about those endpoints. So every single API instance within AWS has to have something called a stage. And a stage is simply a way to version control your endpoints. So I'm enabling stage version 1. Let's say you do some major refactoring within your SaaS application, and now you want to use version 2 and promote version 2 endpoints, but you want to keep version 1 endpoints so your old clients can still use the old integration of your SaaS application. This method comes from the from this BCFN API version 2 library explicitly. Okay, why it doesn't allow me to go inside that? Can I do it like that? Yeah. So we enable default stage, this one, right? Enable default stage. So what it does, it simply creates another resource called CFN stage. It has a bunch of, let's say, irrelevant parameters to you. And this is what we thought when we created this wrapper around this resource. You really don't need to modify anything within that resource. So we just wrapped it around a simple function, enable default stage. You give it a name, and you forget about any other configuration because it is not necessary. Yeah, so this line of code creates the CFN stage resource, which allows you to version control your API endpoints. Now, this structure creates two resources. One is calls build route, and another calls build integration. Let me show you, let's say, separate instances of those. So if we were to write purely defining AWS resources, so we would firstly have a Lambda integration, and only then we would have a route. Okay, and the route key could be something like post slash integration. And finally, a function, you would create a Lambda function that handles that. So in order to create an endpoint for a serverless API, you need to create two CloudFormation resources: the Lambda integration and the CFN route. Again, this resource is simply a wrapper around the Lambda function. I'm not sure why they wouldn't allow us to specify, let's say, Lambda function directly here. It would be really convenient. We wouldn't need to create this separate useless resource. But again, it is what it is. This is how CloudFormation and AWS CDK works. Well, the main reason is that you might have different targets. You might have a Lambda-based target. You might have an EC2-based target, an application load balancer-based target, and so on. So API Gateway is a pretty flexible service, and it works with other AWS services and other types of integrations. But probably the most popular and the most widely used integration is the Lambda function, where when you hit an endpoint of your serverless API, it simply invokes your Lambda function. And this is what we're doing here. If we are going to create an HTTP post request to the domain name of our API /create, what it will do, it will invoke this Lambda function, right? Because it says target, and it targets the integration. And inside that integration, we have a Lambda function defined. So in very simple terms speaking, if you hit an endpoint, a Lambda function is invoked. It gets all the event data. It, let's say, processes that request. It returns some data, and then API Gateway shows that response to browser, let's say Postman, or any other tool that has initiated that request previously. So this is the amount of effort needed to create a separate endpoint. And again, I think it is quite an ugly piece of code. And what I like to do is to abstract some of that code into a more manageable piece of code. So instead of creating those resources separately, I simply have functions that do that. And some of the parameters can already be supplied without using the method-based parameters. So for example, things like API ID, scope. Yeah, basically that's it. And now what you're left with is you need just to specify the ID, the route key, and the ID of the integration and the function name. Yeah, you don't need to specify API ID or the scope. Okay, now if we compared this file, to this file, the main reason is that this class itself is not a stack. The cat API is a wrapper to this BCFN API v2 API. So if you create that instance in another stack, it will not create a separate stack. It will simply create the API. What we are doing here, we are creating a separate stack, and within that stack, we are creating API-based resources. I think this is the better way to approach your infrastructure. Okay, so let's call it self.api equals API, right? And now we need to update self is a stack, right? It is a stack. And API is self.api. Same here. Self.api.ref. I had to update those lines of code because, as I mentioned you previously, in our workshop, we are having a stack in which we create API-based resources. And in our workshop material, we simply had a wrapper around that initial API. Okay. So now, in order to complete our endpoints, we need to somehow supply Lambda functions, the create function, the read function, the update function, and the delete function to this class. And, well, it is, I guess, a quite simple thing to do, as we have written quite a lot of object-oriented programming code. We are simply going to supply those functions to the constructor. So let's say create function, delete function, update, and read. Let's call those backends. It sounds more beautiful. Okay, yeah. So now when we want to initialize this class, we will need to supply these functions to the constructor. And once those functions are supplied, we will be able to build the create route, the read route, update route, and delete route. I hope it makes sense here. Again, if anything is unclear and needs some re-clarification, please do ask in the chat. And the last line of code is CFN output. And this is a nice, convenient way to expose some of the properties of already deployed resources. So for example, I don't know what the domain name of a newly deployed API would be, right? It's usually some random string generated in the deploy time of the CloudFormation service. So in order for me to conveniently access it, I'm just simply going to output the URL to the CFN outputs, and I'm going to find it in the outputs tab of the CloudFormation console. If I go there, I will be able to find it, that output here. Okay. Oh, you will soon see the real example. Okay. So let's initialize the stack, the API stack, which should be initialized somewhere here. Okay. Again, we need to specify the scope, self, construct ID could be something like API stack. And now we need to supply those create function, delete function, update function, read function. Again, we cannot do it just yet because we need to expose the stack to ourselves. Let's call it CRUD stack. And if we try to call CRUD stack, we don't see any functions. Why? Because we haven't made them available. Or let's say public, exposed within the class, right? This is Python and programming related exercise. So simply call it self.create, expose the create function, expose the delete function, the read function, and lastly, the update function. Okay, now these things are exposed programmatically. And now if we go to here, we see delete, create, update, read. These are not the best names because they kind of indicate something else. They indicate an action. We should call them delete backend, create backend, and so on. Naming resources properly is probably the most important thing in software development. This is a pro tip to you guys. Naming things properly will save you a lot of time, will save you a lot of discussions, and will save you a lot of potential chaos. So be very, very mindful how you name your variables, classes, file names, projects, and so on. Anyways, now we can continue on building the API stack, right? So create backend is going to be CRUD stack dot create. Read backend, CRUD stack dot read. Update dot updates, and finally delete backend is. Now, referencing resources from one stack, from one stack in another stack, and this is where we are referencing them, creates automatically a dependency between those stacks, meaning that this stack cannot be deployed until this stack is deployed. So there is a direct dependency from API stack to CRUD stack. And if we were to use this parallel deployment library that Laimonas has created, it won't give us any benefits, right? Because there is a direct dependency between those two stacks, and these need to be deployed in sequential order. All right, I think we're good. I think it should work. Hopefully, I'm just checking any details. Scope, self, ID, API, self API.ref. Okay. Okay, so everything seems legit, but somehow I have some bad worry that exactly something won't work. So API stack object has no attribute enable default stage. Let's check it why. The reason it doesn't contain that name is because we have imported API from BCFN API version 2. That is very strange. It should contain this stage. If we go here, we see that it has. Wait, where was it? Authorizers enabled default stage, right? Self. That's strange. Self dot build routes. Oh my God. Yeah, again, silly mistake from my side. Self calls the stack, right? Because it is the stack. And we want to call the API. So we need to call self dot API dot enable default stage. And now everything works just fine. Yeah, these mistakes happen quite a lot in infrastructure development. Fine. Now, the same thing goes here. It is not self.full URL. It is self.api.full URL. Okay, we found that bug already. And it's deploying. Let's go to the CloudFormation template. It's updating, right? And as you can see, the API stack has not yet appeared because firstly, we need to manage, create or update the CRUD stack before the API stack is created. And now, as you can see, the deployment of the first stack was successful, and now we are deploying the API stack. If we refresh the page, we see that API stack deployment was initiated. And as you can see, it was quite quick. This one is, I think, lagging behind. If we go to resources, we see that we have successfully created an API. Its stage, and as you can see, those create integration, create routes, delete integration, delete routes. So what Šarūnas meant that he already identified my mistake. He's correct. It's not self. It was self dot API dot something. So Šarūnas, kudos to you. You were quicker than me to identify the problem. Yeah. Now, if we go to outputs, this is where we see that output that I mentioned you here. So if we create this kind of CloudFormation-based resource, it will appear under Outputs tab. And it should have given me something like that. Oh, well, I guess it is what it is. This one, right? Because I have specified here the scope, not self, but the scope, meaning I have specified a parent stack which will contain this output resource. If instead I would have specified the self, this output would have been in this stack, as it should, right? But since I accidentally specified their scope, this was deployed into the parent stack. And this is, again, another common mistake that you will do accidentally over and over again, mixing parent scopes with current scope and so on. But anyways, we do have the endpoint. Let's quickly check, do we have the API itself? So if we go to API gateway, yeah, we do see that we have an API to manage cats. It is the same ID as we saw here, right? And if we go inside, in the routes, we should see 4 different methods, right? Create for the post, delete for the delete, read to get, and update with put protocol. Or should I say type? Okay. However, if we tried to test this API, it would simply not work. Let's simply convince ourselves that it will not work. Okay, so let me try and have the create endpoint. I will simply change it to that. And as you can see, I have already played with it. And if I send post, it will immediately give me an internal server error. And it doesn't matter what I'm going to do, it would always give me the internal server error. And the reason for that is that every Lambda function that is integrated with this serverless API needs to output a very specific structure, a very specific response to API gateway service. So let's give it an example. So if I want for the, let's say, create method to work nicely, I need to, and I'm again very lazy to write the code myself, I would simply go to the create function and I will copy this part. Okay. So I need to return a dictionary which has at least 2 values, the status code and is base64 encoded. And again, this comes from official AWS documentation. Again, if you want to dig deeper, what kind of responses are possible, you can always check the documentation, right? This workshop is not about that. But now if we had something like this, and let's simply go to, let's say, delete function and deploy it via console, it will be a little bit faster. Whoops, wrong button. And if we go to delete and we use the new API, right? If we send it, that. delete/delete JSON. It should have worked. Let's try and test it. Test, save, test. Okay, so the response is good. Hello world, delete. Yeah, I totally forgot another thing. And the problem it doesn't work is permissions-based problem. And again, I totally forgot about that. And many new guys also forget about the permissions between a Lambda function and an API gateway. And the first time I faced this problem, it took me at least, I know, 2 or 3 days of debugging and trying to figure out what's going on. And as it turns out, a simple integration between an API gateway and a Lambda function is not enough. You need to create a permission for the API gateway to invoke the Lambda function. And if we would go to our workshop code, and if we went to backend.py, there is this permission resource that it allows the Lambda invoke function action for the API gateway.amazon.com principal. So in order for this to work, we would need to redeploy our, let's say, delete function in this manner with this CFN permission. Okay. So let's try that for the sake of understanding if our infrastructure is going to work or not. Let's try it. So delete function. So let's say self.delete.function name. It will allow to invoke, and function name is self.delete.function name. So now we have specified the explicit permission for the API gateway to invoke the Lambda function. Let's try and do that. But before that, maybe we could immediately copy and paste the code to the delete Lambda function. What else? Cannot use tokens in construct IDs, of course. Meaning that for specifying the ID, we need to use pure strings instead of dynamically resolved values. So calling something like self.delete.function name will not immediately give you a fully evaluated string. It would rather give you this kind of string, which after the deployment is being dynamically resolved into a fully qualified value. And AWS CDK does not allow you to use these tokens when specifying the IDs. So you need to, make it something more simple, like delete function invoke permission. Okay, so this should work just fine. All right. We see our stacks being deployed again. And once our CloudFormation stacks are being deployed, I want to underline another problem with the beauty of your code. every single time, if you want to define a backend Lambda function, you need to create the function itself, right? Yes. It is not enough, as you saw. You need to define the permission. If we start using DynamoDB tables, we would need to specify permissions also for the Lambda function to do specific actions against those DynamoDB tables. So it would look something like that: self.delete.add to role policy. And here we would need to create a policy statement. And inside that policy statement, now we define actions, principles, conditions, and so on. And it becomes ugly very, very fast if we define all of our functions, their permissions, and so on within the same class, right? It becomes very hard to read. So there are two strategies how you can reduce the amount of code within the class definition. So either you create separate files for each function. So you would have a file like create function.py, delete function.py, update function.py, read function.py. Or you would move that repeating code to a base function class, right? This inheritance polymorphism thing that comes out of the box in object-oriented programming, which allows you to reuse code by inheriting from parent-child classes. So in my example, this is exactly what I did. I created a base function, which I just simply called backend. And it is a simple wrapper around the original AWS CDK-based function resource. However, it has out of the box the permission to be invoked. It has out of the box some environment variable sets. And it has two nice methods: grant read for the DynamoDB table and grant write for the DynamoDB table. At the same time, those functions return the instance itself, allowing to chain those calls, further saving some space, some real estate in your class definition. So we should exactly do the same thing, but before that, let's ensure that things are working this way also. Okay, now let's test it. And okay, it works. Now, if we try to send the HTTP request, hooray. So everything worked nicely. The response is 201. This is exactly what we defined within our code. So the permission to invoke Lambda function was the only missing puzzle piece. Fine. Let's go back to that code reusability and polymorphism and create a wrapper around the original function instance. Again, I'm too lazy to write the code myself, so I'm just going to simply copy everything. And I think for you, it's also more convenient to skip some boring parts because, again, there isn't much value to write every single line of code by myself. It will just prolong the whole workshop and it will make it less interesting. So let's create the backend or or we can call it base function just for the sake of object-oriented programming style, base function, right? And that base function is going to base function. And since we haven't created that DynamoDB table, I'm going to delete this part. I'm going to delete this part, and we don't need these also yet. So the base function is very, very simple. The only thing it currently has is the resource, is the permission resource. Sorry, it's a permission resource to be invoked by the API gateway. And it's out of the box specifies ourselves a handler and a runtime. Because again, this is also code duplication. In every single function definition, as you saw, we are specifying the handler, the runtime and the handler, and all of them are always the same. So why to put in the constructor if we can define it immediately here? Now, instead of having this, instead of using this one, we will use base function. Let's go back and now replace the original definition with base function. Okay, and we no longer need these things. Base function, and so on. Now, we can simply delete these two parts as they are already defined for us. And now, as you can see, our code became immediately easier on eyes, right? It became easier to read, to understand, to comprehend. Yeah, so let's simply try to deploy and ensure that, again, everything works nicely. Yeah, and without waiting for the stacks to be deployed, I'm being cautious about the time. It's already more than an hour of this presentation and less than an hour left. So I really want us to be able to finish to finish this presentation maybe even earlier than 6 p.m. So we will immediately jump to creating DynamoDB table. And as I mentioned previously, DynamoDB is a database service provided by AWS. It is a serverless database, meaning it can scale up and down, and you pay per requests, not per hours. And it is a NoSQL database, meaning it is quite fast. And DynamoDB, when integrated with like something like Lambda functions or EC2 instances, can give you amazing performance results. For example, some GET or query queries can return the response in less than 10 milliseconds. And this whole scanning includes the traffic forwards and backwards, right? So meaning that the query needs to go through the internet. The database needs to do that calculation, that initial scanning, and needs to return the response through the internet. And it takes less than 10 milliseconds is pretty awesome. And well, one of the main reasons why data, how do I say that? Data communication between two microservices is not slow via internet. It is because usually DynamoDB table and the Lambda function are within the same data center, and they are connected with high throughput internet cables. So they do not need to go around the globe to reach each other. It's usually there's these metal machines are sitting usually next to each other, so there is no internet connection penalty, let's say like that. So DynamoDB is a great database to use in combination with a Lambda function. This is what I wanted to conclude. Okay, so let's do that. Let's create a table, and for that, obviously, we need to specify another dependency, and it is called DynamoDB. DynamoDB. Let's install the dependency. Workshop stack. Okay, and again, one pro tip for you is it is a good idea to divide your application into stacks, as I already mentioned, but for the storage resources, you should also have a separate stack. For example, you shouldn't create a database here in API stack or a CRUD stack. It is quite a good idea to create a fully new stack, let's say DB stack, and have only one resource within that stack. And the reason for that is sometimes you want to redeploy parts of your infrastructure, or let's say all of the infrastructure. In some certain scenarios, you cannot do that because it involves destroying your database, and your database might have vital information, right? So having this database in a separate database stack allows you to destroy whole infrastructure around, but leave the database intact. And then you can just initiate another deployment. All of those APIs, all of those Lambda functions will be created from scratch again. And your DB stack, your database within that stack, will not be affected. And trust me, you will want to delete those stacks from time to time, because if you decide to refactor your architecture, it is basically impossible to update it. You need to destroy your infrastructure and redeploy it if you're refactoring it fundamentally. And at these scenarios, having storage resources in a separate stack saves you a lot of headache, saves you operations to back up the data, then restore the data, and so on. So this is a pro tip for you. Always use a separate stack for your storage resources like DynamoDB, S3, RDS, and so on. And this is what we are going to do here. Let me copy this part. Okay, stack. Let's call it DB stack. Let's have some imports. And let's create a database. So in order to do that, we simply need to import DynamoDB table class. And what parameters do we have to supply to that table? Again, there are quite a lot of parameters. Thankfully, most of them are not necessary. The necessary ones are the scope and ID, of course. So let's have that. So scope is going to be self. And the ID is, let's say, I know, cool cats table. There is something missing. Let's see. Parameter partition key is undefined. So when you define, when you create a new DynamoDB table, you need to define which parameter is going to be treated as a partition key, and the partition key is going to be used for hashing your values and putting in certain places of database nodes. You can look at DynamoDB as a big dictionary. When you put a new value into dictionary, you also need to hash that value and automatically put somewhere into the RAM slot. It's done for you, but under the hood, this is how dictionaries work, and this is how basically DynamoDB table also works. So we need to define the partition key, or the key if we're talking about Python dictionaries. And partition key is an attribute. So let's create an attribute instance. We need to create it. Now the name could be, let's say, I don't know, cat name, because the names of the cats, of those cats, won't change. And the type is attribute type. And there are a few types. It could be a number, it could be a string, and it could be a binary. There aren't any other values. So the name of the cat is obviously going to be string. And that's it. This is how easy it is to create a DynamoDB table. So let's go back to our workshop stack and initiate the DB stack. And we need to specify what? The scope, DB stack, and that's it. Yeah, I think that's it. Yeah, let's try to deploy it. And within the console, in the search bar, we can write DynamoDB. This is the entrance point of the service. And after a few seconds, we should see a new table appearing here. Okay, it's still creating the change set. Okay, again, let's not wait for it to be completed. Let's go back to that base function. And you remember that I have deleted some of the code. Let's go back to that code. And I have specifically deleted the cat table, the DynamoDB table, because as I mentioned previously, if our Lambda functions will want to access that table, they will have to have that permission. And not just any kind of permission, but very specific actions. So for example, these are the read actions, like describe table, get item, scan, or query. And these are considered write actions, like put item, delete item, update item, or batch write item. So I have separated them in two different functions, like grant read permissions and grant write permissions. For example, the read Lambda function doesn't really need the write permissions, right? So we will give that function only the read permission. Okay, so what we can do is copy everything again. Wait, yeah. Call it again base function. And instead of cat table, just use polymorphism principle and allow us to supply a table. And hopefully it is a cat table. All right. Okay. So what has changed? We are adding some information to Lambda environment. Now, what is Lambda environment? Let me quickly show you. So for example, if we go to configuration and we go to environment variables, we can add some variable, let's say test, and the value is going to be 1, 2, 3, right? These variables can be some configuration variables, like an endpoint to some kind of API, or some password, or some API key, whatever. And the Lambda function can now dynamically access that environment by simply importing OS and calling os.environ, and now simply calling test, right? So it should work. And now you can see it was able to successfully access the operating system level environment variable. And this is exactly what we're doing here. We don't want to hard code into the Lambda functions the table name or the table region for them to access. We want it to make it dynamic. Let's say if the name of the table changes, we will not need to go to every single Lambda function and edit their references to that table. Those references will immediately be updated, and new invocations of those functions will look to the new DynamoDB table. So this way, through the environment variables, we can make our Lambda functions code more dynamic and more reusable. Okay. And when it comes to these functions, they simply either grant read actions or they grant some write actions. Okay, so I see that we've been quite over some time. So let me be really quick, because yeah, I told you that we have quite a lot of material going on. So we have grant, we have read action, and all of those base functions will be able to access access those methods. Now if we go back to CRUD stack, now we see that in order to create that those functions, we need to supply the cat table, right? And we would need to exactly do the same thing. We would need to have table defined here, and something like that. So cat table equals to table. And now, for example, the create function will definitely need the grant write permission, the delete, let's say grant write, the read grant read, and finally update grant write and grant read, because it needs to know which values to update. Okay, so since we are quite over our time of our workshop, I'm going to pause here, and I'm going to encourage you to go to Laimonas Sutkus /AWS CDK serverless repository and open the source code and analyze the source code here. So this is the layer which we missed in talking about. I think it is a really cool functionality, but again, let's skip that part, or it's up to you guys and I guess Cloudvisor to decide if we want the version 2 of the AWS CDK from zero to hero workshop, right? Because there's quite a lot of material left. So if we want the second part of this workshop, I know, just let me know after this workshop is done. Okay. So let us imagine that we have successfully created the API, we have successfully created Lambda functions, the DynamoDB, and we used Lambda layers to share code and share dependencies, more specifically PynamoDB or RAM. And yeah, I would really love to have these things for the second part of that workshop, because I think they are equally important. Because here we talked about that zero part, air quotes, right? And writing integration tests and creating CI/CD pipelines is the air quotes the hero part. This is how I would treat that. But anyways, let's scroll down all the way down to pro tips, and have my vote for the second part. Awesome. We already have one vote for the second part. It means that the first workshop was good. Okay, so let's immediately skip for the pro tips. And probably this is the most important slide of all. And this information probably is the most information of anything I spoke to you today. For some reason, when I'm looking at the tutorials within YouTube on how to work with AWS CDK and how to create resources, I have never ever seen this pro tips to be shared with the public, and I suspect that is because the ones that create those YouTube tutorials haven't digged deep enough to this tool to be able to share those pro tips. And I've been with AWS CDK for at least the same amount as it was out, like three to four years, and I had quite a lot of pain points with AWS CDK, and I can share that extremely valuable information with you. So I mean, I can't stress enough how important these pro tips would be for you if you chose to go the AWS CDK path. So I would definitely recommend you to take a screenshot or to write it down or to memorize it and use those tips when you build AWS CDK based infrastructure. So let's quickly go one by one. I will be very brief. So first one is, please be aware of stack limits. As I told you, currently the limit is 500. Don't use nested stacks, use normal stacks, because nested stacks are just a part of the parent stack, and those stacks still accumulate as one. So you might have this illusion that those resources are separated, but no, they are still counting as under one rooftop. So use separate stacks, not nested stacks, and be aware of those limits. I have already mentioned you this, have separate stacks for storage type resources. And the main reason is that you might want to destroy your whole infrastructure. And by having the separate stack of storages, you can easily destroy your whole infrastructure except the databases and redeploy everything back. This is really important. You need to reduce dependencies between stacks to minimum. And there are many ways how to achieve that. You can try and use DNS servers. You can use SSM parameters and things like that. And the less dependencies between stacks, the more parallel they can be. And again, when you need to destroy your whole infrastructure, if you have bare minimum amount of dependencies, it will be very easy for you to destroy that infrastructure and to redeploy it. So this is a very vital point in creating robust AWS CDK-based infrastructures. Another tip, and this is a must, do not share Lambda layers between stacks, because once you update a layer and you want to redeploy, everything will just crash because there are two dependencies between two stacks. And when you update a Lambda layer, basically a Lambda function needs to be deleted and redeployed with the new layer. And this causes some problems for the CloudFormation. So do not share layers between stacks. If you have some Lambda functions in one stack and you have some Lambda functions in another stack, create two layers, one for one stack and another for another stack. And this way you will avoid some problems. There are many things that AWS CloudFormation cannot do. And for that, you can use custom resources to achieve some custom functionality. For example, you want to create some Twilio-based infrastructure within Twilio, right? Obviously, CloudFormation doesn't have Twilio-based resources, but by using custom resources, you can achieve that functionality and create infrastructure as code in, let's say, Twilio platform or Azure platform or Google GCP platform. And yeah, the imagination is your limit. Another tip is to use third-party constructs that are created by individuals or companies like by Mapas, Identify, or myself or any other individual, because they vastly expand the functionality of the AWS CDK library. You will definitely, for example, not find a resource that allows you to deploy up to 2 terabytes of data within the AWS CDK. But again, Biomapas has created a resource that allows you to move around some limitations of AWS and upload up to 2 terabytes of data. And things like parallel deployments and so on. Another pro tip is you should definitely try and use asynchronous stack deployments. And as of now, I think Biomapas is currently the only one company that has created such tool. I have shared this tool with the original AWS CDK developers, and I said, why wouldn't you implement this functionality into your code and make it like default? And they said, yeah, it looks interesting, and they just simply downplayed. I don't know, maybe they don't care too much about this functionality. Also, another tip, you should definitely have automated CI/CD pipelines, and you should have dev stage and prod environments. Because if you're now utilizing the infrastructure as code principle, you should go all the way to the best CI/CD practices and have pipelines where you commit something to the branch. It triggers a pipeline which, let's say, deploys the testing infrastructure, runs some tests, then destroys the infrastructure. And if all those tests passed, it only then automatically deploys to your dev stage and finally prod environments. And another very, very important thing is don't try to define your whole application within a single AWS CDK application. because if you do that, you will end up with a distributed monolith. And trust me, distributed monolith is way worse than a traditional monolith application. So in order to avoid that, divide your application into different and separate AWS CDK applications. So for example, if you have notification functionality, have an AWS CDK app for that. If you have analytical functionality, have an AWS CDK app for that. And divide your application into these smaller pieces, and you will see that the deployments will be faster, the tests will be easier, and so on. So everything will be much easier to manage with separate AWS CDK applications instead of a single big and monolithic one. Okay, and this is pretty much it. I'm really sorry that I took 2.5 hours of your time. I really hoped it would take just 2, but apparently there's quite a lot of material, and I see that there is still quite a lot of material to go. So if you're interested in the second part, please let know the Cloudvisor, and then we can make the second part. But for now, thank you guys. If you have any questions, you can write now, you can ask later, you can go to community channel and so on. So back to you, Joseph.
Yeah, thank you very much, Laimonas. And yes, the CDK is definitely a big topic. So yeah, thank you for condensing all your knowledge in the time that you did. Yeah, and thank you everybody for attending. Yeah, we really appreciate it. So just the last thing from my side, please remember to look at our benefit packages that I mentioned earlier. You qualify for those packages when you switch your AWS billing to Cloudvisor. And also don't forget to look at our loyalty program, where current clients of Cloudvisor can get up to 1,200 euros in prizes per company that you refer to us. So I'll share both those links with you in the email tomorrow, along with the recording of the workshop. And that's it all from our side. Again, thank you very much for attending. Thank you, Laimonas.
Thank you, everyone.